Everyone intuitively has a good understanding of who they are. When we look in the mirror, we have very little trouble identifying this image as our own self. And we can also pretty quickly identify other individuals.
From a young age, kids can easily count the number of sheep in a field or the number of individuals in this bee colony. The basic act of counting seems to be a trivial exercise, one that we don't need to think twice about. But if we look more closely, we can see why things aren't so easy. To start, we could say that there is only one real individual here, the entire colony. Much like our bodies, it has reproductive organs, the queen, limbs that carry out the day-to-day tasks of the hive, the workers, and a place for everyone to live and interact together, the hive itself. No, they're not entirely connected, but neither are your blood cells to each other. And if we look closely at any one of these bees, we can see millions of individual cells inside them too, not to mention all the bacteria crawling around inside their digestive systems. Which of these are actually individuals? To answer this question, we'll need to look at one of the oldest questions in all of philosophy. One that both Eastern and Western philosophers have pondered for thousands of years, and for which we still have no dominant answer, let alone a consensus. The question: who or what am I? This also seems like an easy question at first. Just draw an imaginary border around my skin, everything inside of that is me, and everything else is not me. But it doesn't take much at all to see why things are much trickier than this.
Take this baby photo. Supposedly this person is the same me that I am now, but we couldn't be more different. For one, this Jake is way shorter than I am now, has hardly any of the same memories, and has only experienced a fraction of what I have. Sure, we have the same DNA, but so do identical twins, and they're clearly different people. From a purely physical perspective, this Jake and I share almost nothing materially in common with one another, because our body replaces 98% of the atoms within it every year. Multiply that out over 20 years, and this Jake and I are completely different collections of stuff.
But I still call this person me, mostly because it's in a photo album with pictures of the rest of my family. I recognise them and can therefore conclude that this must have been me from the past.
Despite that inference, I have no personal recollection of picking up this phone, yet I still call this person me. Isn't that at least a little strange?
The Greeks certainly thought so, and to see why, they came up with a now famous thought experiment known as the ship of Theseus paradox. It goes something like this. Imagine I have a ship. For the sake of tradition, we'll call it the ship of Theseus. As the ship floats around, its parts slowly wear out and are each replaced in turn with new parts. After 30 years or so, the crew members notice that they have replaced every single piece of the ship, such that no part is original. The Greeks then pose the following question: is this ship the same ship of Theseus, or is it different? For reference, let's call this 30-year-old ship with all new parts Ship 1, and now suppose that as each part of the original ship of Theseus got worn out and thrown off the ship, some nefarious thief went along, gathered up each part, and put them all back together to form a ship that looks identical to the original ship of Theseus. If we call this Ship 2, then which one is the real ship of Theseus? Ship 1 or Ship 2? Both?
Intuitively, I think most people would say that Ship 1 is the real ship of Theseus, because we are Ship 1. Pretty much all of my parts have been replaced from this baby photo, just like the ship of Theseus, but I still call this person me. Ship 2, on the other hand, is a much more foreign concept to us. It's not like there's some thief going around collecting all the pieces of dead skin that are falling off me right now and putting them back together into some kind of clone. There are other solutions to the paradox, but one really interesting one has its origins in Buddhist philosophy, specifically with the concept of anatta, which translates roughly to non-self. Buddhists consider this one of the three marks of existence, and it is the teaching that there is no underlying, permanent entity that we can call the self. Rather, there are only aggregates which come together to form something that we can call me.
These are form, sensations, perceptions, mental activity, and consciousness. Each of the 5 aggregates is always in a constant state of flux within you. Consciousness fades in and out as we sleep and wake up, and as our hair gets long and we grow taller, we change our form.
Often anatta is mistranslated as the teaching that there is no self, but this is not quite right.
This mistranslation has been called the granddaddy of fake Buddhist quotes. Buddhists understand that there is some kind of self when the 5 aggregates come together, but it is impermanent, or anicca, and always in flux. The Scottish philosopher David Hume used these Buddhist ideas to coin his own bundle theory of the self, which extends the number of aggregates from 5 to an arbitrary number, and that at any time we are just a bundle of such properties or perceptions. In Hume's philosophy, that is as close as we can get to defining what we are, and that is indeed all we are. When I enter most intimately into what I call myself, I always stumble on some particular perception or other, of heat or cold, light or shade, love or hatred, pain or pleasure. I never can catch myself at any time without a perception, and never can observe anything but the perception. With all of this in mind, we get a nice answer to the ship of Theseus paradox. Neither ship 1 or ship 2 is the real ship of Theseus, because the ship of Theseus doesn't exist. At any one point in time, there is just a bundle of properties of the ship. The brown colour, streamlined nature, heavy weight, and so on. These constitute an impermanent and transitory thing which we happen to call the ship of Theseus, but which is really just an illusion.
Even this doesn't go quite far enough in answering the question of what am I? Because if the self is just a bundle of properties, then what properties am I meant to include in my definition of the self at any one time? Do we include the properties of all the bacteria crawling around on my skin? And what about the parts of my mind that I store on my phone, like people's birthdays or phone numbers? They're all properties that have something to do with me, but it's not clear which of them we should include in the bundle definition of the self. If we look at species other than humans, we can see even blurrier cases of individuality.
Take the slime mold Dictyostelium discoideum. When given plenty of food, Dictyostelium lives its life as a single-celled organism and reproduces by cloning itself. But when food becomes scarce, something amazing happens. All the individual single-celled Dictyostelia send out a signal to aggregate into a multicellular slug. During this phase, each of the individual cells begins to release adhesion molecules, allowing them to stick better together. This slug then moves to an ideal location, collecting more single-celled Dictyostelia along the way, and eventually morphs into a fruiting body that can release spores. The spores start off their life as single-celled organisms, and the cycle repeats. This is truly bizarre. Do we now count the slug as an individual because it kind of reproduces and is one contiguous mass? Or is it simply a collective of individual cells? There's no clear right answer.
Cases like these highlight why Chris Fields and Michael Levin argue for ditching the notion of discrete individuals entirely. It's just too messy. But if we do this without a substitute theory, the world turns into unstructured goo, just a bunch of chemical reactions and stochastic processes. But this can't be right, because we can clearly see patterns in biology that are more than pure chemistry.
The motor proteins in our cells look like the cells in our blood, which in turn look like humans in a crowd, which look like cars on the freeway. And where there are observable patterns and structures, there must be theory. So where can we go now? The first step out of the goo is to treat individuality as a spectrum. The way we arrived in this messy view of biology was by attempting to categorize things definitively as self and non-self. Inevitably, a bunch of problem cases cropped up, and we got really confused. If instead we allow individuals to be more nebulous, we can maintain the structures we see in biology without running into ontological nightmares. One starting place in constructing a spectrum of individuality is Darwin's theory of natural selection itself. This is the basis of Peter Godfrey Smith's concept of Darwinian individuals. Godfrey Smith defines such an individual as an entity that exists in a population that can evolve by natural selection, or more specifically, using Lewontin's criteria, an entity that exists in a population with variation, differences in reproductive success, and inheritance of traits from parent to offspring. Importantly, the capacity to be naturally selected exists on a spectrum. Some nice cases of clear Darwinian individuals include humans, mammals, fruit flies, and so on. These can all evolve by natural selection. Viruses too are Darwinian, as we have seen through the rise of each new COVID variant, natural selection happening before our eyes. Or, even more strangely, things like memes can also be considered Darwinian individuals. Actually, this is the origin of the word meme. Richard Dawkins invented it to describe a packet of culture that can evolve by natural selection, not just an image with text scribbled on it. So, TikTok dances that become recognised worldwide would be, in Dawkins' sense, highly successful memes, and in Godfrey Smith's framework, also decent Darwinian individuals, since memes can reproduce by spreading through minds and have some sense of heredity. Though it gets trickier when we start to ask whether groups of entities can evolve by natural selection. Some cases are easy to work out, like a herd of sheep which can't really be seen to reproduce and is therefore not Darwinian. These are just a bunch of individuals, not a single one. But compare that to the honeybee colony from the start of the video. These have some sense of collective reproduction because of the clear division between reproductive and non-reproductive parts. So, group selection is possible, and honeybee colonies have some Darwinian individuality. But this still remains a hugely contentious topic among biologists. Notice here how we avoid making a clear distinction between individual and non-individual like before. It's all continuous. Godfrey Smith notes that not all living organisms are Darwinian, particularly those that can't reproduce. This includes very basic trouble cases, like mules, which are sterile, as well as trickier cases, like the slime mold slugs from before, which have a messy system of reproduction. We want to say that these things are still individuals, just in a different sense from the Darwinian ones. Godfrey Smith lumps these cases into another class of entities which he just calls organisms. This is a fine solution, but biologists are still pretty unsure of how exactly to define what an organism is. Some even argue that no definition is possible at the moment, which we'll dive into more depth in the future. So that leaves us with a nice set of objects to analyse, Darwinian individuals, and a hodgepodge of other things. On top of that, we have left behind something from all this philosophy from before, particularly the Buddhist idea that the self is impermanent. In this Darwinian framework, we are suddenly considering bees and sheep as permanent entities again, which leads, as we saw, to the ship of Theseus paradox. To bring everything together, we actually need a significant mindset shift. Up until now, we've mostly looked at individuals through what they are made of. That is, we've taken individuals as collections of stuff and investigated the properties of that stuff to determine what an individual is. This is known as substance ontology. But some philosophers and scientists say that we may have gotten it all wrong, that we shouldn't be looking at what organisms are, but rather at what they do. And from what we've discussed so far, we've identified one obvious thing that all individuals do. They change. No individual is same from moment to moment, and we are in a state of eternal flux. It is this change that defines who we are, not substance. When we place this kind of thinking at the centre of our theory, we get a philosophy known as process ontology. It originated in the West with the philosopher Heraclitus and his teaching of everything flows. And we've just started to take this approach by defining individuals via the process of natural selection. But we can take it further by looking at a fragment from Heraclitus himself. Ever newer waters flow on those who step into the same rivers. One interpretation of what Heraclitus means by this is that a river is not defined by the water that makes it up. A river is the process of water flowing. Think about it.
if this water stopped flowing, then we wouldn't call it a river anymore. We'd call it a pond.
Here we get a different perspective of existence, that even though our atoms are constantly shifting through our bodies and our consciousness in and out, we are still the same individuals.
Organisms are not made of atoms. Organisms are processes through which atoms sometimes flow.
This philosophy of process ontology is yet to fully penetrate itself into biology, but just 2 years ago, it got a long-awaited reboot via the mathematics of information theory. This new framework was spearheaded by David Krakauer, and it gives us a clear start in using process ontology instead of substance ontology to understand what an individual is. It works like this. Start with an aggregate of something that you want to test for individuality. This could be pretty much anything: a cell, a crowd of humans, or a symbiotic relationship. Now, we define an individual by one key process: its capacity to propagate information about itself forward in time. For instance, a cloud has some degree of individuality because its future state will be at least partially due to the information currently contained in it. But this form of individuality is very rudimentary because the future of the cloud is controlled almost entirely by external factors: the wind, heat from the sun, and so on. On the other hand, more autonomous individuals, like this lone wolf, tend to have a higher degree of informational individuality because they are much more in control of their own fate compared to any other factor. Of course, the external environment will play a role in the future state of any system, and this is where the mathematics comes in. Depending on how tight the interaction between system and environment and how much information comes from either source, we can get different levels and different types of individuality. Using the concept of informational individuals, we can analyse one of the trouble cases from before, our gut microbiome. If we exclude them completely from our individuality, we'll be leaving out some arguably significant future information. This is because the microbes in your gut moderate your immune response, help you digest food, and can even determine your mood. In return, they get food to eat and a place to live, so you also impact them. All of this interaction will be missing from our picture using the internal system alone. If we could know the precise amounts of all of these information flows and plug them into the equations given in the paper, we could determine whether it makes more sense or not to leave out the microbiome in the definition of this individual. But remember, everything is always continuous and there's no clear-cut picture. Krakauer himself even notes this as an intermediate case.
Clearly, it's not the two independent individual world lines. Neither is it one. It's something in the middle. It's this grey zone.
This process ontology allows us to have this undulating and fluctuating view of individuality. There are some clear lines though, like if I don't interact with something, then it can't be a part of my individuality.
Or even if I touch this tree, I impart very little information into its future self, and it imparts very little information into my future self. Our fates remain distinct, and it doesn't make much sense at all to tie us together as a single individual.
But if a koala moved in here and started eating the tree's leaves, then the tree and the koala would share much more information with one another, making them more like a single individual. On a more pragmatic note, applying all of this to our day-to-day lives can fundamentally change how we see the world. That every time you sip your morning coffee, in that moment you are expanding your individuality ever so slightly to include a new process that will impact your future self. Every time you mindlessly scroll through TikTok, the algorithm is impacting your future thoughts, and depending on what captures your attention, you alter the algorithm to act in a certain way, changing its future self. Together, you become intertwined with it and form a kind of informational individual. Perhaps on a more positive note, as we spend more time with our friends and family, they quite literally become a part of who we are. Since what they say to us now, what experiences we share with them, and what advice they give will all contribute to who we become in the next year and beyond.
We are not static things, gigantic lumbering robots whose only purpose is to reproduce. We are whatever we choose to do with our lives, and however we pass on the information contained within us to our friends, family, and to our future selves. Thanks for watching.